So in this section, we're going to talk about functions, and functions can get very complex very quickly. It's a prelude to what we're talking about when we talk about scope. But a function, at its core, is a way of breaking code into reusable chunks. Before you, we have our typical diagram of start and end. So we have the start of a program and an end, and a program normally does not do this. It doesn't normally just start and end. There are steps that we take in between, hence that's why we have a computer program. So for example, we've done things like this, where we have an if statement, and then we could make some sort of decision based off the logic. But you know what? Life isn't always that simple. So you're going to see me just destroy this diagram in this video, so forgive me in advance. But let's take a very simple example, and once you start thinking of the logic of it, it's not that simple. We're going to make a calculator that calculates your age in dog years. Okay, not too hard. We've done that, so dog years. But then somebody comes in and says, well, you know what? It'd be really cool if we could take that same thing, and instead of dog years, we want cat years. Ooh. And you're like, okay, well, I guess I could do that. I mean, I could kind of take this and just kind of, figure out some logic here using an if statement. Okay, got it. So if it's, they want this or they want that, then I could just do it like this. And it makes kind of sense when you think about it this way. But then before you've even finished writing the program, somebody else comes in and goes, well, yeah, cat ears and dog ears are cool, but, what about fish ears? Okay, well, I guess we could try fish ears. So now we've got fish ears. And then somebody else comes in and says, well, what about bird ears? Guys, this is getting a little out of hand here. And then someone else comes in and says, what about Wookiee ears? Wookiee, like Chewbacca from Star Wars. How old is that guy? He's ancient, right? Okay, so using what we know so far, what would make the most sense here? We don't want billions and billions of these little if statements out here. I mean, we would have these things all over the place trying to figure out the interconnections and how this one moves to this, and see, how would we even start wiring this thing up? I mean, it would be some crazy haphazard mess, and it would get ugly fast. So somebody out there is probably shouting the switch statement. Yes, switch statement. That would be a little more ordered. And you could actually write this program in this manner where you could say, okay, got it. Let's move these over here. And wow, and we're running out of screen real estate, but we could do something like this, right? And then we could just have, I'm just going to grab a rectangle rather than put all these out here. This, and then let's just grab this. And let's just say switch. So we would have a whole big switch statement, which would figure out which one of these we actually want to do. And then we could use an enum and say, I got it. Birds is 0, dogs is 1, Wookiee is, why Wookiee? I don't know, 3, and then fish, and then cats, and this and that. The problem comes in is when somebody else says, yeah, but what if I want to reuse that logic in an if statement down here? You see how now suddenly this doesn't help, because now we've got to take all of this and put it over here where it's usable for this guy. And this will get very, very confusing very fast, and then you find your program doesn't work, or you're rewriting large chunks of code and none of it makes sense at all. This is why functions exist. So let's just get rid of some of this garbage here. And get rid of this. So now I'm going to wave a magic wand in the background, and each one of these blue blocks here is now a function. Now, when we talk about function, it's just a logical bit of code that defines something. It's just a block of code that we're going to be able to call. So we have other things out here. So let's just grab something like this, and then like this. And this would just be the basic flow of execution of the application here. There it goes. Didn't want to work with me. And it doesn't matter. Say in this iteration, the user wanted dog ears, and in this one, they wanted fish ears. And you can reuse this code over and over again. So when a year from now, somebody else comes in and says, you know what? I want this guy over here, but I want this one to call this one, and this one should call cat ears. You can very easily reuse this code, and you can make very complex applications using functions. So I know this looks horrendous from a diagramming perspective, and there are vastly easier ways of doing this. But what I'm really trying to illustrate here is that you can make a complex program very simple by streamlining things, and you can very easily add new things into your application. So let's say this little yellow guy is a new addition, and reuse the existing code rather than having to rewrite whatever cat ears generates. It makes it extremely simple and extremely easy once you wrap your head around it, but there are some caveats and gotchas, which we're going to talk about in this section. So this is our intro to functions, and the big surprise here is that we've been using functions this whole time. We just haven't really realized it. So look at this int main, this guy right here. We've kind of said, just, take it for granted, drink the Kool-Aid, find your happy place. This is a function, but we haven't really explained what a function is. Well, main is the main function or main entry point, and inside these little brackets is the block of code which we're going to execute. That much we understand, but we can now make our own functions, and let's go ahead and demonstrate that. So I'm going to say void test, and then qinfo. I should note I already had the include qdebug at the top there in case you're wondering how I got that magically in there. And then hello from test. So what's so special about this? Well, let's say we wanted to do this and put it in here. You could very easily do this, but it doesn't really have good code reuse. So we're going to make this function called. To do that, we put the name of the function and the parentheses, and then a semicolon. We are now calling that function. Save, run, and let's see what this looks like. Hello from test. Now, this may look a little crazy if you're not used to functions, but read it like this. The compiler is going to start at the top, and it's going to start reading down. It's going to go, I need to include everything in there, and I need to include everything in here. And then, I have a function, so I'll remember the name of this function. And then it's going to keep going until it finds main. And when it finds main, it says, I know where to begin. And it's going to start executing the code using everything that it's read so far. So it's going to go in here and go, all right, so I have some arguments that are being passed, which at this point is just data. And that data is going to be what I need as the application to start. And then I'm going to start a qcore application with the variable of a using argc and argv. And that looks very confusing, but it's just information being passed to us by the outside world. And then we are going to do something. And we've been working in this scope or the main scope right here. But now it's saying, test, I remember reading about that. It's up here. So it's going to jump up here and execute this code. Very cool. Now, one thing you understand here is that we now have code reuse in our application. We can call this any number of times. See? Watch. Meaning, once we have created this function, we don't have to recreate the reel. We just call it. We're just telling the computer, hey, I want to run some code, but the code's really located in this function called test, go to test. And it's a lot like telling it to go to a specific spot in a book or a dictionary or something like that. It's saying, go find it somewhere else, and the computer knows what to do. Now, one thing I want to note right up front is a lot of people go, you know what? I don't really like it here. So I'm going to make my other function down here. That's right, you can have more than one function. Now, first thing you'll notice, it's saying redefinition. That's right, you can't really have two functions of the same name. Now, I'm just going to say it for all you people that know a bit of C++. Yes, that is 100% not true. You can have two functions with the same name when we get into classes and things like that. But for the purpose of this conversation, no, you can't. We're not talking about overloading or anything like that just yet. What we're talking about is basic compilation. It's saying you can't have it because we are on the main or the global scope at this point. So I'm going to name this 2. Notice how it thinks it works just fine. So I'm going to grab this guy. I'm actually going to say test2. And I'm going to put it right here. But you notice how it's saying use of undeclared identifier test2. What does that mean? It's literally, I'm staring at it. It's right here. What is wrong with you, you dumb computer? And if we just say, you know what, maybe it's a bug in the IDE, I'll just try to run it, we'll see that it surely is not a bug in the IDE. It's saying use of undeclared identifier, and then it even is very smart. It tells us, hey, you don't know what you're doing. So why? It's because it reads from the top down. What's happening? Again, the compiler's starting here. It's going down, down, down. It knows what test is. It's going into main saying, this is where I start. And then it says, okay, I know what this is because it's up here. I know what this is because it's here, but I haven't heard about this thing yet. And there's all sorts of other tips and tricks that you can use, but we're trying to keep this very, very simple. For example, you could use a prototype, which we're not really going to discuss because we're going to show just enough C++ to get you through Qt. The end goal here is to make this simple, so we just simply move it up here. Just remember, C++ reads from a top-down approach. So now, even though the IDE is still freaking out about that, if I build it, notice how it magically disappeared before it was done building. We can run this, and it now works as expected. So some major takeaways here. When we are working with functions, we are creating our own scope, and we're going to really dive into that in this video series. But also understand we can make chunks of code and make them callable, and they are little independent islands that don't know the others exist. Now, that's not exactly true. So for example, test, if we try to call test2, we're going to have that same, hey, I don't know what you're talking about issue here because it's reading from the top down. Okay. But we could do the opposite, where test2 can call test because test is already above it. This is why includes exist. It really solves this problem. And we're going to talk about this a little bit more in depth. But really, what includes do is it tells the computer, hey, put this at the top and know what this is before we start reading any of this stuff. Some other major takeaway here is if you forget to put the parentheses and you do something like this, it has no idea what you're even talking about. It's saying expression result unused because it doesn't know what that means. So let's try running this and see what happens. Okay, so we got hello from test2. Let's comment this out just to make sure that it's actually working. Let's see what this does. It's not crashing our program, but it's not really a valid expression. It's not a valid statement at all. Once you put the parentheses in there, it magically knows what you're trying to do, and it says hello from test. So this can get very confusing, and this honestly is just the very tip of the iceberg, but I wanted to give you a very high-level overview of this. And the main driving point of this video here is that you need some sort of data type, you need a name, and parentheses, and then the scope block. Notice how void is a data type. Void means literally no data type. We're going to talk about how you could return a data type. For example, you could return an integer, but for now we're just going to do void. And then parentheses here, these will be the parameters that we will give to the function. So much like the main here, we can get things from outside. And we're going to really dive into that. The other major top-down approach here is something you need to really drill into your head. Once you really understand that it reads from the top down, you can fix a lot of problems on your own, but you'll see a lot of people make the mistake where they'll take like test2 and drop it down here, and they wonder why it magically doesn't work anymore. So when in doubt, remember the top-down approach. This video is going to be, well, a 2-for-1. We're going to talk about function parameters and returning results. Why? Because we want data to and from a function. You notice how our main here has parameters. So we're sending information to, and it has a return. So we're returning information back to the operating system. The operating system itself is, well, just another program. So let's go ahead and let's make some functions here. Int calc. And let's go ahead and do something like this. Int offset and int age. So really, what are we doing here? Well, we're making a function called calc. We're saying we're going to return an integer, and we have some things we're requesting. If you're going to use this function, you need to give this function an offset and an age. Both of those are integers. The parameters are separated by commas. Now, first things first, it's saying unused parameters. I'm not worried about that just yet, but it's also saying a non-void function does not return a value. Notice non-void. Void is a data type saying there's nothing there. So we need to return something. In this case, I'm just going to return 0, but we should do something because the function is named calc, which assumes we're going to calculate something. This gets into a whole other topic called naming functions, but at its core, a function should be a human-friendly name, meaning you should be able to read it and have a vague idea of what it's going to do. So for example, you wouldn't make a function called calc and have it turn off your refrigerator. That just would drive people insane. So calc is going to, well, calculate things. I'm going to say int x equals offset times age. And then we could just say something like qinfo and I'm putting that in there so we know when we call this function. It's very simple, very straightforward once you read it. And because we know that it reads from the top down, main has an idea of what calc is. All right, well, that's pretty simple. Let's go ahead and test this out here. So let's jump in here and say int age equals 0. And then let's go ahead and say qinfo, enter your age. I think we've kind of beat this up a little bit using your age as an example, but it is actually pretty easy to understand here. So we're going to ask the user for their age. And now we can call this directly here. So I can say int value equals calc. And notice how the IDE is smart enough to know what we're trying to do. It's saying in that little yellow box, int calc, int offset, and then int age. So it's telling us, see that bold text here, offset, what is the offset? So it's a lot like just reading instructions. Okay, it needs an offset. I'm going to say 2. And then the age, let's just say whatever they entered as an age. And then we need our semicolon at the very end. And then we can take this value and do something with it. And let's say value, and I want to know what that is. Go ahead and run this, see what it looks like here. All right, so let's say our age is 34. Calc being called is now 68, and value is 0. Uh-oh, value 0. What did I screw up here? That's why our return value is 0. So here's lesson 1. Brian makes mistakes. So we need to return that now. So there's your lesson in return. I actually was going to highlight that, but I'm kind of glad I made that mistake. It's going to return literally whatever you get it. So we could have simplified this whole thing into one line by saying this is now this, but I want to work with this variable here. So that's why we have this in multiple lines, and we're going to return that out. Now when we run this, it should work as expected. Silly me. All right, let's try that again. 34 is now 68. So calc is returning 68 and value is 68. So if you ever have a problem with a return value, you probably made the mistake that I just did, where you just put in some filler just to get that warning out of the way. because I tend to fill in the function and then do the return and then work in between. So fixes that problem. All right, now this isn't cool enough. It's just not. Somebody comes in and says, hey, let's say the marketing guy comes in, we're going to calculate cat ears and dog ears. Oh gosh, could we not? Okay, here we go. You remember that big diagram at the very beginning of this section? That's what they're starting to go down. They want all these things. So I'm going to say int cat ears and then int age. Notice how we're not asking for an offset because we're going to manually use that. We'll say return, and I want to do calc. So we're calling the calc function that's right above us. And cat ears, I think cat's aged 9 years to every human year. Maybe wrong about that. And then we're going to use the age. So notice what's happening here. We have a function that's getting a parameter, and we're taking that value and using it as a parameter to another function. And then we're actually returning the value of this function. So this is quite common where a function will call another function and simply return the value of that function after it's done some other things here. So for example, we could say QInfo performing math for cat ears, something like this. And they make it seem all big, but really under the hood, they're just calling some other function. And we could even take this to another example and say dog ears. Now the offset for dog years, I think, is 7 years to every human year. And it becomes a very simple, very easy pattern to understand. And then we could do something like this. So let's say double, because that's our double and our age. And I want to actually say age. Age. There we go. Now let's do this. So we're going to say cat ears. There we go. And we're going to feed it the age. And then let's go ahead and do the same thing for dog ears. Now, if this looks really confusing, you have to kind of pause and think about this in terms of how a computer would think about this. And this is why programmers get paid just a metric ton of money. So from the top, let's look at this. What are we doing? Function parameters and return results. Why? Because we want data to and from a function. And here's how. So we have our function calc, which is going to do some high-end math here. We're just multiplying an offset by an age and getting a value and then returning that value. And then cat ears is just going to take the age and then we're going to manually pump in the offset of 9. Dog years, same thing, manually pump in the offset of 7. And our application, we're just calling functions. And this is pretty standard for an application. Rather than doing everything in the main, it's just simpler and easier to put everything in nice, easy to understand functions. So a function should be simple, easy to understand, straightforward, and should do what it says it does. Dog years should not calculate the number of fish in the ocean. It should calculate the number of dog years. All right, so let's run this, see what this looks like here. So let's say you are 21 years old. Your age would be 21. Calc is going to say 42. Double of that is 42. So 21 times 2 is 42. Performing math for cat ears, you would be 189 cat ears. Performing math for dog ears, you'd be 147 dog ears. This at its core is extremely powerful. You can break your program into logical chunks that are reusable. So we have cat ears and dog ears, and notice how we can put that in line with our QInfo. We don't actually have to make a value, grab it, store it somewhere. We just put it right there. Makes it super easy to use. This video, we're going to talk about function flow control. We've talked about functions. We've talked about flow control. Now we're going to put flow control inside of a function. So we've done this before. We just haven't really realized it. We have the start of our application. We have the main, which is actually a function, which is going to return out and end our application and signals to the operating system, hey, we're done. Now, in the past, we've done things like this, where we have this, but it's all existing inside of our function, whether we realize it or not. And it's been a little bit, well, sheltered. We're going to change that. So I'm going to grab all of this, move it over here, and my drawing skills are not 1000%, so bear with me if I have issues, but we're going to grab this guy, and we're going to make some functions. So I'm going to paste this, and we're going to say dog ears, and of course cat ears, because you got to have cat ears. Which, of course, in the background is going to call another function called calc. We've done this before where it has this offset and all this other fun stuff. And it would look, well, something like this. Let's see if I can get the mouse to cooperate with me. And then in the background, each one of these is calling this calc function here. Close enough. All right, so both of these is going over to calc. So when we go into main, we're going to call dog ears, which goes over to calc, and main is also calling cat ears, which goes over to calc. They have different offsets. I think this was 7, and this one was 9. There we go. Now what we're going to do is in calc, we want some sort of logic saying, is this even a valid year? So this will go out to, well, an if statement. And that if statement's going to say, hey, make sure this is a valid range. And that range should be between some number between like 0 and 120 or something like that, because we don't want somebody putting like a 3,000-year-old person and then you have this immortal cat, because you just can't have immortal cats. I mean, what would the world come to here? But this is the basic flow of what we want to do with our application here. So let's jump in here and figure this thing out. I've got some boilerplate code in there. We're using QCore, application, QDebug, and IOStream, and using namespace std. And I've got some code in here where we're just grabbing the age from the user. All right, let's start with our hard one first here. We're going to go int calc, and we're going to say int offset, and then int age. And this is, of course, got to return a value of some kind, so I'm just going to return 0 by default. And, well, we can, if we wanted to, through the magic copy and paste, just copy and paste. So I'm going to say cat ears. And we are going to return calc. And we want to do 9 and age. And then let's go ahead and do dog ears. And I think dogs are 7 years to every human year. So that pretty much fits what we're doing here. Now we just need to have our main call these two, which is calling that one. So let's go ahead and fill that out right now. And I'm going to say QInfo dog. And then let's go ahead and do cat ears as well. Now somebody out there is probably going to say, hey, now wait a minute. Why isn't this working? Well, it's because C++ is what's called case sensitive. You see, this is a lowercase y, and that's an uppercase y. So when in doubt, if you have something like undeclared identifier and you're literally looking right at it, check your case sensitivity. See, magically cleared it up. Someone else is probably going to be saying, well, do you have to do them in line like this? No, you don't. You could have very easily said something like int cat equal cat years age. And you could have done the same thing for dog if you really, really wanted to. Doesn't really matter which way you do it. However, you will note sometimes if you don't do it this way, you may get some weird C++ errors, so you'll tend to see this kind of thing in the real world here. And then from here, you would just replace it with this. All right, so we've got the core functionality of our application going here. And if we were to run this, everything's just going to return a flat 0 because, of course, calc has got 0 by default. Now, let's go ahead and fill in the hard part here. So first thing I want to do is say if, and we're going to put some logic in here. That's right, we're using flow control inside of a function. If offset is equal 0, then we want to qfatal this out, which of course is going to kill the entire application. We're going to say offset cannot be 0. And then we're just going to completely kill the app. Now, we want to do a little bit more professional logic here. So I'm going to say if, then we want our parentheses, age is less than or equal to 0, or age is greater than 120. So I'm sorry, if you're 121 years old, this program simply will not work for you. Then we want to do something like this. Qfatal. And you don't have to do a fatal, but I'm going to do it just to demonstrate here. We're going to say invalid age. And if you're watching this video and you're over 120 years old, hats off to you. Let me know and I will modify this code. Now, once we get to the return, then we're just going to simply say offset times age. And what's happening in the background here is C++ is putting some hidden parentheses here like this, and it's calculating that out, making a variable, and then returning it as a value. But we're going to let C++ do its magic for us, and it should just work. So quick recap, in our function, we're saying, look at offset. If offset is 0, fatal this thing out. If the age is less than or equal 0, or age is greater than 120, remember we've got the or statement here, so either one of those could be true. It will trigger this little block of code here, which will fatal out our application with invalid age. If we can actually get to this point, we're going to return offset times age. All right, let's take a look. Save, run. Let's try a good number, something we know is going to work. I'm going to say 37. So if you're 37 years old, you are 259 dog years or 333 cat years. That would be one really old cat, one really old dog. Close that. Let's try and break this thing. So I'm going to enter 0 and invalid age, closes it out. And let's give me a really, really old person, invalid age. So everything's working as expected, but this really shows you how powerful you can make an application, because now you can have a function that has flow control inside of it. Okay, if ever there was a video that was going to cause me to use bad words, this is that video. I absolutely do not like function overloading. So you remember in the previous video when I was talking about functions and I said each function had to have its own name, and then I immediately stopped and said, unless you're talking about function overloading, this is function overloading, and you're going to see exactly why I don't like this. So function overloading is the same function, I should say the same name, but with different parameters. And let's dive in and take a look. So I'm going to say void test, and we're going to keep this very, very straightforward. Qinfo. This is a test. Very simple, very easy to understand. Now, if we grab this, paste it, notice how immediately we get that redefinition error, redefinition of test. So C++ is smart enough to know this thing already exists and you can only have one. Or can you? So I'm going to say qstring name. Notice how now it's just warning me you have an unused parameter. All right, well, let's use it. Now that works. We can even build this thing and it builds without any problem. All right, so let's take this to an extreme now. So I'm going to say test, and I'm going to say int age. So far, it's really not that bad. You may be wondering why I don't like this, and you're going to see here in just a second. Just bear with me while I get the code out there. So what's really going on here is we have a definition, and that definition is based off this line right here, whether you have a return value of some kind, the name, and then the parameters. So for example, test, and this one is going to say bool is active. And then in here, we can just do some simple logic. So I can say if is active, and you may be going, oh, wait, whoa, don't you need like a equals true or something like that? No, because remember, if we'll look at these parentheses and evaluate that to a true or false, we already have a bool, which is a true or false, so we don't need this. We can just simply go like that. And then else. And then I can just grab this right here. And almost done typing, I promise. I know this is the boring part, watching me type. All right, now, I'm gonna show you a little trick here. You see these little arrows, and when I mouse over it, highlights the code. You can actually collapse code down. That's right, really cool. It's called code collapse. And we're gonna collapse all these functions down. Just so you can see what I'm talking about here. We have 1, 2, 3, 4 different test functions. Each one has a different definition. We have void test nothing, void test with QString name, void test with int age, void test with bool is active. All right, so let's just play around with this. I'm going to say test and then parentheses, and you notice how it says 1 of 4. So C++ is smart enough to know we have 4 of these, and you can use the keyboard down or up, or you can, if you're good with the mouse, you can click these little arrows. And you can see the different definitions as I kind of scroll through them. Now, what you have on the screen and this yellow box can be two different things. So this yellow box is just a suggestion. It's telling you what's available. I'm just going to do this. Save run. And this is a test. So what's happening is C++ is compiling, it's running, and it's going down and saying, okay, enter into our main test. I know test exists and it has that definition, so I'm going to call this version of test. Okay, well, let's do that again. Let's do test 42. Well, what are we doing? We're handing that an integer. So it's going to run and it's going to say age 42, and then this is a test. So it's saying test 42. Ah, this is an int. It's going to look at these and go, ah, it's this one. And then test with no parameters, it's this one. And that's how it works. Now, this may seem extremely cool and you're inclined to just start making a whole bunch of test functions. And let's go ahead and do that now. Let's just play around with this. And what one haven't we done? Oh yeah, we haven't done the test and you're going to see this more in Qt5 and older code where you go like this. And so the expectation is that anything in these quotes here, Qt is going to automatically convert to a Q string. Notice how there's no errors. We can build this. Everything builds as expected, and we can even save and run. But what is happening here? Let's look at this. You see Brian Cairns in there at all? You don't. Ooh, that's scary. So we've just introduced a bug into our program. So let's comment these out. And the only one that's going to run is this guy right here. Let's save and run and see what's happening. Testing for active. Yes, this is active. Now, wait a minute. Test. And we have a string is actually going down to this test bool is active. This is a subtle bug that will creep up and just completely bite you in the backside, and you'll spend hours trying to figure this out. So what's happening under the hood here is when we look at this, and I just mouse over, you see that the in between the quotes is actually a char constant array of 13 characters. Or I should say an array of 13 char constants. So C++ is trying to figure out the best guess for this and going, well, it's not this, it's not this, it's not this. Why not? Let's just throw it in here and figure out what happens. And it doesn't crash the program. That's scary because now I had no intentions of calling this. I meant to call this. And C++ is just doing whatever it thinks. Oh, that is scary. That is very scary. So let's show you another issue. Let's say I say test 57.09. Since C++ is so smart and can figure out how to convert things on its own, it's not converting. Instead, I get this call to test is ambiguous. What? Let's try to run this. Test is ambiguous. You're going to get this time and time again, and you're going to spend hours trying to figure out what ambiguous means. And if you click on it, call of overloaded test double is ambiguous, and it's going to tell you this is what you're trying to do. This is our best guess, but it doesn't work because double and int are two different things, and C++, is not going to convert that for you. Oh, that is frustrating. The next best guess is this bool is active. So what it's saying is it doesn't know which one of these to call automatically. You saw how it called with this Brian Cairns, it called this bool is active. It doesn't know which one to call, so it's saying it's ambiguous. Short version, whenever you see the word ambiguous, it means C++ is very confused and doesn't know what to do, and it's panicking, asking you to fix it. There are multiple ways to fix this. You can either A, hard code this into an int, or you could cast it into an int, which is something we haven't really covered yet, or you can make another overload. The problem is you end up with millions and millions of overloads for every specific case, and it becomes a complete nightmare. And as you've seen, the functionality of each one of these is vastly different. So what's the difference between testing for age versus testing for a bool? Very different functionality. So to fix this, you need to give it the correct data type. And this is something, if you're familiar with Q5, you really need to pay attention because it no longer automatically converts that for you. Now, if I save and run, because we're giving it the correct data type, it's going to say name Brian Cairns and work as we expect it to. And then the rest of this will just work. Now, this is a prime example of why I absolutely hate function overloading, because you can run into all these crazy little errors that cause all these issues in your programs, and your program may compile, it may even run, and then just work completely unexpectedly, and you're trying to figure it out. Remember, the general rule of thumb with a function is it should be easy to understand, and it should do exactly what it says. We have 4 test functions that do 4 completely different things. So my advice would be test, test string, test int. I mean, actually type in test int. You know, that way it's a completely different function and you know what it's actually going to test. All right, if this course did not give you a headache before, this video certainly will if you're a newcomer to C++. So what are we talking about? By reference and by value. What does this even mean? Well, it means we as the developer have to pick and choose how we send data to and from functions. So for example, in the UI, I have C++ allows us to have total control. Value is a copy. You're going to see that word over and over and over again in this course, copy. We recreate or create a copy of that entire object. So we're actually handing a value, where reference is the actual object itself. That is confusing. So whenever you see value or by value, you are making a copy. When you say reference, you're giving it the actual thing. Let's take a look at a simple drawing here. So we have a main function and a test val function. And let's make a little circle here. And let's say this represents an integer. In our main function, we're going to call test val. So it's going to do something like this. I'll call that. And we're going to take this integer and give it over to test val to let it do something with it. But if we're doing it by value, we're not actually giving it that variable. We're giving it a copy of that variable. So what we're really doing is this. And a lot of people don't understand this, but what happens is if you try to modify this, so for example, if I just click that and let's go over here and let's just pick a completely different color, you make some sort of modification. That modification does not go back to the original variable, as we're about to see. This is good and bad. It's good because it protects this original variable, but at the same time, it's bad because if you made some change, you expect that change to go back to where you wanted it. Let's go ahead and observe. So I'm going to make a function here. I'm going to call this test val, and I'm going to say int x. We've done something very similar. We've seen this before. So we just have a return type of void, so we're not going to return anything. We're going to say the function name is test val, and we have an integer named x. And in here, I'm going to say x equals. Okay, this is where we need to pause and think about what we're doing. We're actually taking this parameter, which in itself is a variable, and we're going to assign it some sort of value. We're now changing that. So what's happened here is before we've even called this, we are passing by value. We're making a copy of this. And to kind of further expand upon that, QObjects, which we haven't really talked about, QObject is the base class of all objects inside of Qt. So whenever you see copy and Qt, think this is bad, because QObjects do not like being copied. So we're going to have to be very careful in the future when we do something like that. So anyways, we're going to say x equals x times, and let's just say something simple like 10. Well, let's go qinfo test val x. That way we can see exactly what's going on. Now, in our main function here, let's go ahead and say int x equals 5. Notice they are named exactly the same, x and x. So a newcomer is often going to look at this and go, well, it's the same thing, it has the same name. And this is why it gets just so horrendously confusing. So I'm going to say qinfo main x. And let's pretty that up a little bit here. And then we're going to call this test val function with x. And then let's grab this one more time just to test it out. So looking at this code, a newcomer is going to go, okay, so x is 5. We're going to go into test val. We're going to give it x, and we're going to multiply x by 10. So it's going to obviously be 50. And then this one will be 50. So can you guess the values here? Well, this one's easy. This one's 5. This one's 50. And this one is, if you said 50, I'm sorry, you're wrong. It's actually 5. And there's a reason for that. What we're talking about really encroaches on a conversation about scope. But remember, each little block of code is a scope. It's kind of its own little island. And what we're doing is we're handing it a copy here. So when we modify that copy, it's not going to modify the original. Let's run this and see it in action. So sure enough, main x 5, test val x is 50, but then when we go back to main x, it is 5 again. So what's really happening here under the hood is that delicate dance that we described. So we're creating this, we're handing it, and we're actually making a copy, and we're handing it the value. And it gets way deeper than that, and someone in the comments is going to say, you're not actually creating a copy, you're creating a clone of the value, and they're going to word it slightly differently. But basically what's going on is we are creating a copy of that and handing it a value. It gets super, super frustrating. Now that copy, remember, we are modifying the copy, not the original. And when we get to this point, I should say right here, the copy is destroyed. That is super, super confusing for a newbie, but that's essentially what's going on inside of memory. So that is passing by value. And you notice that's what we've been doing this whole time. And that's exactly what's happening right here in our main. Or is it? You see that little star? That is a pointer. Pointers are a bit more advanced. We're going to talk about them later. But it alludes to what we're about to talk about, which is a reference to an actual object. Now, references and pointers are similar but different. We're talking about a reference, which basically says, here is where the object is located. Very, very similar to a pointer, but they are kind of different. So let's go back to drawing land and let's talk about this. We're going to take this same model here. And we're going to go down here. And we're going to say test ref. We're going to make a whole new function. And we're going to call that function. And this time, when main calls test ref, instead of making a copy, it's going to say, here is the actual object, or, thing in memory, whatever it actually is. If we make a modification to it, when test ref is done, it actually has modified that original object. So in reality, it's something like this. They share that object, whatever it is, whether it's an integer or a class or a cat or a truck or an airplane, doesn't matter. They share it. And I notice those are slightly offset. That's going to just bother me for some reason here. See if I can, whoops, not really skilled with the mouse today. There we go. So that is the main difference here is by value will make a copy, by ref will hand it the actual thing. So let's take a look at that. We're going to pass by reference. And there's multiple ways to do this, as we're going to see later on in this course. I'm just going to show you probably the dead simplest way. I'm going to say int, and let's say ampersand y. Notice the special character right here, the ampersand. Basically what we're saying is address of. We want an integer at the address of whatever y is. And then we're going to take this right here, and we're just going to modify the code. I just want to show the exact same code with the different thing. And now right here, we're going to do this again, and we're going to say int y. And then let's change this. And this. And there we go. So instead of a copy, we're handing a ref or a reference, which is the original. There we go. So because this is the original, this is actually memory. This is a location in memory. We're basically telling it to go out to and modify. So looking at this again, y is 5. So here it'll be 5. We're going to test the reference. And in this case, it's got this ampersand. We're saying go to that memory location or address of y. Now that's confusing. Really all we're doing is we're saying this guy right here, that y, exists out on memory and it has a memory address. And the ampersand is literally saying go to that address and get that object, whatever it is. Then we are actually modifying that object. So when we get here, it's actually going to be 50. And then here is going to say 50. Let's go ahead and run this. So sure enough, X did exactly what we thought it was going to do. Y, though, what is going on here with Y? Oh, I screwed up. Forgive me. There we go. Up if we had the right variable there. Somebody watching the video probably caught that. Let's do that again. There we go. That scared me, or I thought my computer was broken. So anyways, X did exactly what we thought X was going to do. we have not modified the original. Why, however, we're saying use that address of, and we are passing that by reference, and we are now modifying that original. So the major takeaway here is C++ allows us to handle memory in multiple ways, and it can get very confusing. You see how I got a little tongue-tied and twisted towards the end, even though this is a simple example, and I'm an experienced programmer. See, I'm already tongue-tied. Memory gets very complex, and what we're talking about here is the complexities of how a computer sees that memory. So, by value, you're making a copy. By reference, you're accessing it using the address of, or the ampersand. Now, later on, we're going to talk about pointers. And pointers point to a memory location where address of says go to the address of. They do virtually the same thing, just slightly different. I was very hesitant to make this video, but I wanted to cover it just because you're probably going to see this out there. Functions inside of structs. So what are structs again? They're data structures. We've talked about this very, very limited. So a data structure is, well, just that. It's to represent data. It's not something you should really have a lot of functions in. However, some people just want to watch the world burn. That's right. Just because you can do something doesn't mean you should, and C++ gives you an arsenal of tools to do something. Now, I'm not telling you that doing this will, cause global warming or bad things will happen. I'm just saying it's probably not the best method. There are better methods, and they're called classes, which we'll talk about later in this course, but I wanted to show this because someone out there is going to bring it up. So let's go ahead and make a data structure here, or a struct. So I'm going to say struct. Call this laptop. And let's go ahead and add weight. Now let's go ahead and add a function in here. The thing is, I'm very hesitant to do this because it goes against everything that I've learned as a programmer. Data should not manipulate data. That's what classes are for. However, you can actually do this, and this is kind of mind-blowing if you're coming from another language that doesn't allow this. So let's say we want a double as kilo. Well, I'll just say grams. That way, in case somebody doesn't know what a kilogram is. There we go. So we've got a function called as kilograms that's going to return a double. And we're going to return a value, which is the weight. And I'm going to level with you. I cheated. I went out to Google and said, how do I convert this? And it gave me this magic number here. So 453592. So don't hate on me if this is incorrect. Google gave me the answer. I cheated. So this structure now can actually take the data and give you some alternate version of that data that doesn't actually exist. And that's kind of dangerous if you are banking on this as kilograms never changing, but then you turn around and change this, bad things are going to happen very quickly. So just to demonstrate this, I'm going to say laptop. Let's call this a notebook. I know, very, very creative name. Let's call it notebook. And so we're going to say notebook dot weight. And let's say this is a very heavy one at 5 pounds. And then you can do something like this, qinfo. And notebook.weight. And then let's go with kilograms. Now, you notice how this is a function, so we have to have that parentheses at the end. It's going to return the value. You can do this, and it does work, although it's probably not the best method in the world. So pound versus kilograms, there's your answer. Again, I give no warranty or guarantee of any kind of this algorithm being 100% perfect. I'm just showing you, you can put a function inside of a struct. Now let's talk about, should you do that? My response to that, feel free to disagree, is no. Why? Because a structure should represent the data. I don't think you should do this inside of the struct, although with C++, it's perfectly legal to do that. You are on the fly manipulating data, and a structure is meant to represent data. So because that data is changing, the representation of the data is changing with it. I know that's a very probably lame answer, but I don't believe this is the correct way of doing it. I think if you're going to have a function, this function should exist outside of the structure, and you should manipulate the data in the structure, not on the fly, but when the structure is created. That's just me as a developer, although there are hundreds of millions of examples of data structures that get manipulated on the fly. Now, I did say I believe there is a better way, and what we're talking about is classes. We haven't really talked about that too much, but a class is a blueprint for an object, and we're going to talk about classes later on. All right, to wrap up functions, let's talk about how functions can return values. And we've touched on this before in other videos, but we haven't fully explained it. And if you've gone off and experimented on your own, you're probably very frustrated. This video will hopefully clarify why and how to fix those issues. So what are we talking about? Functions can return values. Now, this is a bit misleading when I say values because we can return all kinds of things as we're about ready to see. Now, why? We need to take care of how and what we return, or I should say what and we return and how. That gets a little confusing. But you have to understand from a C++ perspective, we control the memory, but to a degree, C++ also controls the memory. So now you have two different things vying for power to control the memory. This video is going to touch on classes and pointers, and we're going to return a value and return a pointer. Now we keep talking about pointers, values, and references. So I did find this really great explanation, and I did copy and paste it in the notes. What is the difference between a pointer and a reference? Well, a pointer in C++ is a variable that holds the memory address of another variable. It's literally a variable that points to another variable, or I should say points to a memory address that holds that data. Think of it like a bookmark in a web browser. The bookmark itself does not have the website in it. It just simply tells the browser where to go. A reference, on the other hand, is an alias for an already existing variable. So notice the difference here. They both kind of do the same thing. A reference is an alias or a memory address, tells you where to go, or I should say tells C++ where to go, but it's already existing. We don't create it, C++ does. We just say, hey, go do this, and C++ just figures it out. Where a pointer, we actually have to take care of this thing. And pointers they're complex. They're really hard. They're challenging, and we're going to talk about them not just in this video, but across this course and even across the series if you go on to my other courses. Pointers are complex, but this is what makes C++ so great and so fast is you can go directly to a spot in memory. You don't have to wait for the computer to figure out where it is. You can just tell the computer, I know where it is, go here and go do it. Now, under the hood, remember, this top one is a by value. We're making a copy of the object. By reference is we're saying here is the address of, and I have this ampersand here, and let me boldface that. So what does a pointer look like? Well, I can grab these. Pointer is going to look something like this, and I'm going to have to scroll down for it. Instead of an ampersand, it's simply a star, and it does essentially the same thing. Let's call this test PTR for pointer. So really all we're doing is we're saying, hey, C++, go to the address of for reference, or hey, C++, go to the pointer at for a pointer. It's really that simple. You have one of three ways. You're either doing a value, which is a copy. Spoiler alert, Qt does not like being copied. You're doing a reference, which is saying, hey, C++, go figure out the address of, or you're doing a pointer saying, hey, C++, I know the address of, and here it is. That's really what we're doing. So let's dive in and take a look. And again, big shout out, I'm not affiliated with them, to Edpresso for that beautiful explanation. I have copied and pasted it right here. So we're going to make a few functions. First one, we're going to get an object. So we're going to introduce the concept of QObject. This is the base class for which all objects in Qt are created. So I'm going to say QObject. QString name. Now, if you're confused about a class, we haven't really talked about them yet. A class is a blueprint. So this is just a data type that Qt has created. See, it says QObject is the class, is the base class of all Qt objects. So when you're talking about Qt, all of them at their core, should say most of them, not all of them, are Qt objects. So this function is going to return a Qt object. We're going to say Qt object O, and then O dot set object name. Name, not really important that you even do this little bit. I'm just trying to demonstrate that we're going to work with some type of object. Return, and we're going to return O, our object. Now, notice how right off the bat, the compiler is getting very angry with me and say, call to deleted constructor of QObject. What is going on here? This is what I meant by QObjects do not like being copied. What's happening? We're creating a variable and we're saying, hey, return that variable. We're trying to make a copy right here. We're returning by value. We're saying here is a copy of that object, which is a huge no-no. Qt does not like doing that. So this simply will not work. It probably won't even compile. I'd be shocked if it did. Let's just see if it even builds. Nope, see, it won't even let me try to build it. So that's not going to work. Just very simply will not work at all. So the only way I can get rid of this is to just comment this out. So I'm going to comment that out for now. So then the big question becomes, how do we get a QObject then? Well, let's try that again. QObject. And I'm going to do an ampersand for a address of get ref. And I can actually just grab all of this, and we're just going to redo the whole thing. And toggle comment on that. Okay, now notice we have a warning. Address of stack memory associated with local variable. There's your key right there, local variable. Again, we're talking about scope. Inside these brackets is an own little island of scope. We are making it right here on the stack. There's two, and we're going to get into this in depth later on, but I want you to understand there's two parts to memory. There's the stack, which the operating system creates for your application, and then there's the heap, or also called the free store, which is literally the memory sitting in your computer, and we have access to do pretty much anything we want to that. What C++ is telling us is, hey, we've created this on the stack, and it's going to be deleted. Because we're asking C++ to manage that memory for us. So because we're telling C++ to manage it, C++ is saying, well, I don't need it anymore, so I'm just going to get rid of it. So if we try to use this, let's go ahead and build it. It will probably build, but if we try to actually use it, it's going to not work. So we got to build with a warning. Let's be brave here. So I'm going to say QObject, and let's call this O2 equals get ref. And I'm going to have to comment out this first one because we know it won't work, but I want it for completeness, which is, of course, get object. That won't even compile, so I'm just going to comment that out. All right, so quick recap before we run this. All right, we know that by value is not going to work. By ref is giving us a warning, and now suddenly it's saying call to deleted constructor. Remember, I did say it will be deleted. So now C++ is smart enough to know that, hey, we're trying to get this object using the address of, but C++ has already deleted it. So back in diagram land here, we're saying use this, but C++ is saying, you know what? It's gone. Doesn't exist anymore. and it's going to crash our application if we try to run it. So if we're back here and we try to run this, it's probably not even going to build now because it's saying call to deleted constructor of QObject. Yep, see, boom, the whole thing just exploded. Now this looks really ugly, but whenever you see use of deleted function or call to deleted constructor of QObject, that's exactly what's going on. You're trying to use a copy or an address of an object that no longer exists. And that is super, super frustrating. So let's comment that bad boy out. And now comes pointers to the rescue. And I'm going to do the magic of copy and paste. We're going to use the asterisk, which signifies we're going to use a pointer. And we're going to say get PTR, short for pointer, doesn't really matter. Now we need to change this a little bit because we are going to manage this. So I'm going to say on the heap, we will manage this. All right, if ever you were afraid, be very afraid right now because this is what we're about to do. Notice how we have to change the syntax. We're going to say data type with an asterisk, meaning we're telling C++ this is a pointer to a variable. I did say at the very beginning of this, a pointer in C++ is a variable that holds the memory address of another variable. So what we're doing is saying, hey, we have a QObject. It's not here, but it's actually here. It seems very confusing, but that's exactly what's going on. And we are going to create a new QObject. Now, this is where if you're in a computer sci class, you're going to spend a week and a half talking about memory allocation and the difference between a stack and a heap and blah, blah, blah. But I'm going to paraphrase it. So really what we're doing is instead of doing it on the stack, which the computer has allocated for us when the program started, we are doing it on the heap or the free store or available memory out on the computer. You ever get a program that takes up so much memory? Cough, cough, Google Chrome. It's because what they're doing is they are doing this, the new keyword. New signifies we want to manage the memory and we want to do it out on the heap. Now, we also have some other issues here. See this member reference type, blah, blah, blah. We have a special syntax. We have to change that to a dash bracket or an arrow, which literally says this pointing to that. So now we have a special syntax when we access things. This will not be deleted. I want to put that in bold just so that stands out. What that means is we're creating something out on memory and it's going to stay in memory. We now have to manage that. So when we go down here, I'm going to say QObject. Let's call this pointer 03. Get PTR. By pointer. We can now work with this bad boy. Notice the only warning I get is value stored in 03 during its initialization is never used, meaning it's smart enough to know that we've never used it. Let's go ahead and give this a good build. And sure enough, the only thing we get here is unused variable. That guy right there. So let's close that and let's see if we can actually work with it. Let's run this and see what it does. Sure enough. And I even misspelled by pointer. You could try and actually do something like this, where we're just going to take that entire QObject and put it out to QInfo. Good luck using cout with that. It probably just will never work. But in Qt, we get something like this, where it's smart enough to say, hey, it's a QObject at this memory location, and we've done the set name of by pointer. So really what we're doing here is we are accessing raw computer memory at this point, but we have another issue, which we will dive into in future videos, but I want to just kind of touch on it now. When I close this application, we did not delete that memory, meaning right here will not be deleted. Oh, that causes all sorts of headaches. Now, most modern operating systems are going to track what programs allocate what memory, and they're going to automatically free that up when the OS closes the application, or I should say when the application tells the OS, hey, I'm closing, but don't guarantee and don't think that that's a guarantee in life. It's just not. And if you were to stop or delete that pointer, you could have a hung pointer and all these other things that we're going to talk about. But because we've done new, we need to now delete. And there's other ways of doing this, but we're going to delete 03. So we are now telling the computer to go out and actually delete that off the heap. Because remember, a pointer is simply pointing to a memory address on the heap. So we're saying, hey, computer, go to wherever this is pointing to and delete it. So when we run this, everything works. And when we close this, it's going to go out to this memory address here, and it's going to delete that subsequent memory for us. All the other things in memory we've done are automatically managed by C++, so we don't have to worry about it. Now, real quick conversation. Again, Q objects do not like being copied. For the interest of full disclosure, I am going to uncomment that and uncomment these when I put it out on GitHub. So if you download this code off GitHub, it's not going to work and you're going to have to comment those things out. I just want all these beautiful little error messages and warnings to pop on the screen for you to see what's going on.